Hello, my name's Mark Howitt, one of the founding directors of Store Electric. What we're about is storing electricity, as the name suggests, and storing it at truly grid scale. We're looking at plants that are huge, 500 megawatts, 21 gigawatt hours apiece. The problem is not just storing electricity, it is how to make renewable energy profitable and how to make traditional energy efficient. Because renewable energy only generates when the climate wants to generate it, and we want to use the energy when we want to use it. So matching the two requires energy storage. It requires it at all sorts of scales, right the way from domestic scale through to grid scale. Domestic scales being addressed by the batteries and also significantly larger scales, but no one else is addressing the grid scale energy storage market at the moment. The scale of the issue is that, as George Osborne said, it would benefit the economy by the energy industry by £10 billion a year by 2050. At the same time, the University of London said that it would benefit the entire economy by £60 billion a year by 2030. So the scale of the opportunity is absolutely enormous. The scale of the market's enormous, and it's global. We've seen a lot of activity around the world wanting energy storage, but not finding technologies to supply it. And in DEC's view, what we're offering is exactly what they're wanting, and it's market ready, and it's technically viable, which is why they're supporting us so far with a small contract and hopefully with funding very shortly. What it is compressed air energy storage. It's extremely simple. We take electricity when it's not wanted, use it to compress air to 70 bar, which is about 30 times the pressure of your car tire, store that air underground in salt caverns, which are very cheap, huge, and naturally hermetic. When we need the electricity and it's not being generated at the same rate, we let out the air, use it to generate the electricity, and put that back onto the grid. Extremely simple, not quite as easy to put into practice, mainly because compressing air expels an awful lot of heat, and expanding air takes in an awful lot of heat. Unmoderated, the compression would heat the air to 600 to 800 degrees C, and the expansion would cool the air to about minus 160, which is a bit cool. So we take the heat of compression and we store it to reuse during expansion. And that gives us efficiencies that have never before been achieved in compressed air energy storage. 68 to 70% efficiencies on these huge power station-sized storage batteries. It's been suggested that it's the world's biggest battery, and all it uses is air, water, electricity, and equipment. So, very simple. Regarding technical risk, extremely low. Siemens say on record, on video, publicly released, that they can make it with their current catalog equipment. They've just never put the equipment together in this way before. That's why they partnered with us, and because they see that it's a business that could make a benefit to their corporate bottom line, which is huge. We've already got an offer of between 4 and 8 gigawatt hours worth of caverns, so we can get up and running very, very quickly. There are locations all the way around the world, lots of intellectual property. We've got some of the best partners you can imagine, and added to that recently, since this was published, was Arup, who are giving us free work. And we're talking with Alstom very shortly. Our program is to build, in 2 to 3 years, a 40 megawatt pilot plant, a 500 megawatt full-scale plant in the next few years, and roll out across the world. We've had a small amount of funding so far, and are looking for £1 million of a £1.5 million fundraise. We've already had £500,000 offered, to which we hope to add additional deck funding. And the market is absolutely enormous, 1,000 to 4,000 installations globally. Thank you very much.